Assalamualaikum students, I want to welcome you all to yet another video presentation wherein I will teach you some assembly language. Maybe I will call it how to find assembly language programs, and that too with the perfect video presentation explanation actually. So here we go. So let's start out things. This is actually, the program is to add two BCD numbers, but it is not just single digits, two-digit BCD numbers, and then display it back. So we got some macros here. I've already taught you some macros, so you must be knowing that these macros. This is the macro name prints str. That's print string, I want to say. This macro definition here will print me some string, definitely, and it has some dummy argument message wherein I will send something from the main procedure to this message. Then it's the usual way to store these variables, actually push AX, push DX out of the stack, and because we're going to stack and they push in first AX then DX, okay, because stacks grow in the memory downwards, not upwards usually, which we think. So first, if I push AX, it will be first pushed here, then it will be pushed down. So we are just printing using the 09H. It is just to request display of a string, and so loading the effective address of the message in the DX, which works because 09H works on the DX register, and call the function interrupt 21H. That's it, and then pop it back. So get the stack back. Whatever you stored in the stack, get it back. That's it. It's very simple. And then here we have the end m. This is the end of this macro, which will print me some string. And then we have another macro, which will get me numbers. So I'm asking user to input two numbers from the keyboard. So this macro will input me some numbers. It will be two-digit numbers, but whole logic of this program is in this procedure. If you understand this procedure, you are done. What does this procedure do is actually when you input something from the keyboard, it is taken as an ASCII. For example, you input 3, and 3 is actually taken as 33, because ASCII of 3 is 33. It starts from 0 because ASCII of 0 is 30. That means if you input 3, it will be taken as 33. So if you input 4, it will be inputted as 34. But what to do with it? Because I'm getting some numbers which I want to input 3. It's getting me 33. So I have to do something to get this 30 part out. So I would simply do what? I will simply subtract 33. Yeah, I will simply subtract 33 with the 30. So let me start it here to let you understand perfectly. So I'm pushing some registers, this stuff, and then I will move 01H into the AH, and 01, this is actually to get maybe one some character, whatever, from the keyboard, and it will get that into the AL. So if I'm inputting, say for example 3, that will be inputted into the AL. So I told you that will be in the ASCII, because whatever you input from the keyboard, that will be taken as an ASCII. If I input 3, it will be taken as 33. So I'm subtracting AL, the ASCII 0. It is as good as saying subtract with 30H. The same. I'm subtracting AL with the 30H or ASCII 0. That's it, because I'm getting that 30 part out, because 0 has ASCII part 30. And what I'm doing then is rotate left AL 04H, because when I input 30, let me show you a little bit here. You just maybe you understand it here, right? Like, because the video is on. The AL register is 8-bit. It has the lower bit has the AL, and upper byte is the AL, and upper byte is the AH. Because AX, if I talk of AX, it is 16 bits long. It has 2 bytes, 8-bit byte, AL and AH concatenated together, and I'm talking this time of AL. So take this off, AL. I'm taking AH off. AL is here. AL is having two nibbles. AL is having two nibbles. Now I'm taking the two nibbles, 4 bits, 4 bits. Okay. Then I'm putting 3 for I want to actually input two numbers. 35. When I put 3, it is taken as 33. Okay. If I input 4, it is taken as 34. So if I input 4, it will take 34. I'm talking of AL now. In the AL's upper bit will be 3 and lower bit will be 4, 34. So I now I subtracted it with the 30, that means ASCII 0. So means this part, the 34, out of 34, 30 is gone, and this is gone, 4 is left. Okay, now 4 is here. But when I input second number, I will do same procedure. For example, I input 5, that there it will be taken as 35. I will take again 3 off, 30 off to get 5, but that 5 will be here on the lower nibble. Similarly, the 4 will be on the lower nibble. I have to do one thing. I have to put this 4 into this part. Okay, so that what happens? This 4 comes here. The 5 is on the lower nibble. Okay, this becomes 45, the number which I want, the BCD. Probably you got it. So that's why I'm doing what? I'm rotating left. AL4. That means rotate AL4. That means get the AL. That because I was inputting 34. So put 4 on this side here on the upper nibble, and next time what I do is now I put this AL into the num. So my num, that is the first number which I will be inputting. That num will have what? 4 here in the upper nibble of AL, like it was AL, now it's a num. Num is again the 8 bits, sorry, 1 byte. So here it will have 4, it will have free space here, okay, in the lower, because I'm gonna put second number here. Now I'm getting with the move AH01H, again requesting display. Maybe you are not getting it perfectly because probably you have not got the basics of assembly language. If you got the basics, then you can understand it easily. If you're not getting it, the moral is that you have no basics. So first clear basics, I would recommend. Then what I'm doing here is I'm again requesting here. I'm again requesting this input. Again requesting input for second number. Now second number input, I told you I have inputted 5, that will be taken as a 35. So take that 30 part out by subtracting with the 0, ASCII 0, that's 30. And then what I do is because my num already have 4 here and nothing here. Now the AL is having 5 here, nothing here. Got it? So I OR it. My number is on the top. It has upper nibble 4, here nothing. My AL, now AL on the bottom, it has 5 here and nothing here. So I will OR the 2. And when I OR it to, the upper nibble of the num will get in, the lower nibble of the AL will get in to make a complete number 45 into the num. So num will have a proper number. That was the logic here. What happened? I probably think you understood. Let me take it you understood. If you're not, then you gotta catch me live, probably. So maybe it's a virtual class. This will help a bit if you have the basics, but if you don't have, then God will help you, no problem. Now listen here. Now print term is the again when I inputted the numbers. Now I'm gonna print it back. When I'm gonna print it back, how I'm gonna print it back? That's here. Because now I got the 45 packet. It's actually got the packet BCD. Now I have packet the BCD 45. The 45 I got a 45 in the 1 byte. Upper nibble having 4, lower nibble having 5. So now when I print it, I have to unpack it. How I will do that? I will put the num, which is having the 45. For example, I said I have a 45 in the num. Okay, I will put that 45 into the AL. Okay, but I will print it one character at a time. So I will print 4 first, but 4 is on the left side. I have to put it on the right side. So again, I will do reverse of what I did previously. I will rotate it right. I will rotate it right four times, 4 bytes, because this 4 actually it will not be like this. It will be in the binaries. So that is 0 1 0 0. That's 4, and lower byte will have 0 1 0 1. That is my 5. And if I want to put this 4 on the lower byte, I have to put 4 rotations to the right, so that this all comes here to take this position of this 5. Okay, so actually what happens with the rotate ROR, the upper byte and the lower byte will swap. The 4 goes here, the 5 goes here, so it will become 1 0 1 here, and it becomes 1 0 0 0 here. So now my 4 is here, now 5 is here. What next I will do is I want to get rid of this 5 to print this 4. So I want to get rid of this 5. How I will get rid of this 5? I will AND this thing with the 0FH. Okay, here the 0FH is like this. 0FH means actually 0 means in hexadecimal 4 zeros. Sorry, I got some flu today. And F means all ones, so we are having all ones like this: 1 1 1 and 1. Okay, it's going to be compact here. Okay, now when I add these things, look, because I put on a 0 in the upper nibble, zeros when added with anything will get zeros results, so this will be cleared. So answer will be like this. Answer will be, these will come to be zeros, and these will, what will come here? It will be what it was. It has got no change. It was 0 1 0 0. It will be 0 1 0 0 when we add with ones, because anything added with the ones will get what is there. A, if I say A added with 1, it will be A. The answer will be A, what it was. But if something A again maybe added with 0, it will be 0. So this, by adding AL with a 0FH, will clear the lower nibble, that means 4 bits, and the upper nibble will be retained. So that's my 4, which I'm gonna print. Now what should I do? I will get this AL into the DL and call the 0 to H function to print it to you. So that's it. But again, yeah, well, I missed the point, because when I want to print it with the 0 to H function, it prints ASCII. So I have to change it back to the ASCII. What I did earlier to get rid of ASCII, I subtracted 30. But when I have to get it back as an ASCII, I will add 30 back. So that is, I'm adding AL with the ASCII of 0, that is 30H. To get it back, it will become as a 34. So 34, when we print, it will print as a 4, because 34 is ASCII of 4. So here we go. So we say add AL with the 0, then move this AL to the DL, because DL 0 to H function works with the DL, and it will print it. It will print DL. That's it. Then it will print me this 4. Now it's time to print 5. Is it? So again, num will have the 45 in it. I will put again same like I put it here, num into the AL. I will put it here also, num into the AL. It will again have a 45. This time around, 5 is already there on the right side. I don't have to rotate it like this. So what I will do is I will only add it with the 0FH to get rid of this 4. So I'm adding here AL with the 0. No, here, sorry. I'm adding AL with the 0FH so that upper nibble gets cleared and lower nibble retains. That's 5. But put in an ASCII, so add AL with the 0. That's ASCII 30, hexadecimal 30. That means ASCII of 0. Then move that AL to the DL to get printed by the 0 to H function. The 5 will get printed. Okay. So I got my print numbers like that, and I pop it. The registers what we have. That's the end of the macro. Now I'm having the macros done. Now starts my program. Here we go. This is a model small. You know that? What is that model small, huh? क्या होता है? बोल गए? Yeah. I'll tell you. No, not a problem. Model small. There are many memory models like tiny, small, and etc. But the small does one thing. It has one data segment and one code segment. Sorry, that is of 64K each. If you take, for example, model tiny, that is used for the COM programs, it will only one segment, that's the code segment. Nothing is allowed. No other segments like data segment. That will be again in the code segment. So, but here we have data segment as a separate. It is it means that it's a model small. So, what we're gonna do here is data num1, in which I will put first number, num2, in which I will take second number, sum, in which I will do what? Very good. Oh, you are very intelligent, huh? Because you know how to add. Great. Then I got a message 1, 2, and 3. Now don't laugh and just concentrate on the concept. So what I'm saying is, please enter first 2-digit numbers. It's a 2-digit numbers, okay? First 2-digit numbers. So you're saying, what is the first and 2? It is first. That means pehla 2-digit number. Okay, mix it with the Urdu to let you understand. Then message second is second actually number, and then we're gonna sum it. That's the message number third, which I will print here. So I will say here code segment. That's a start label, which tell assembler to start from this point onwards. That's important. Okay. This is to initialize your data segment. You know, this is the boilerplate code. You know this thing. Then we have the print str. This print str is my macro. I'm calling that, but sending message 1. I'm sending this time message 1 to the print str macro. What is that? Let me see page up. Here we go. This is the print str macro. I'm sending message 1 to it. So message 1 will get copied with the MSG. I'm loading effective address of MSG into the DX. It actually means load the effective address of message 1 to DX. That means message 1 will be printed. So message 1 is here like this. That means please enter first 2-digit numbers that will be actually printed. Now what you gonna do then? Next, can you tell me? Yeah, when I say enter the 2 numbers, I gotta call my procedure get num, but I will get the number, the 2-digit number actually. That, and I'm sending the num1 because I wanna put that into the num1 in this num1. So I'm sending num1 to it, to this. No, the print. Here we go. The get num. I'm sending num1 to this to get it printed. Printed? No. To get it from the keyboard actually, and store it into the num1. Okay. So my first number will be input. You input the first number actually, and then it will be stored into the num1. Then we got the message here, print string message second. Message second means enter the second 2-digit number, and obviously I will call the get num again to get the second number 2-digit number and store that in the num2. So I'm sending this time num2 to the get num macro. Then when I got the 2 numbers, what I'm gonna do to them? Yeah, I'm gonna add them. So add them just, but you can add num1 to num2 because 2 memory locations cannot be added directly. So you have to use some intermediate. So you have to use what? A register, maybe AL. I used AL. So put num1 first into the AL, then add num2 to the AL. This means add num2 to the AL and store the result into the AL, and move AL. Now you got the AL, the addition of the 2, and put that into the sum, and then I'm gonna do what? Print the sum. That's very simple. So print string message third. That means this thing. This will call the print string macro and print me the message third, and then what will it do? It will print num sum. Then call the print num function. The print num, I'm using only first time here now. That is this function, print num. And I'm sending what? I'm sending it the sum. Sum will be copied into the num and it will work it. I could also print my numbers, num1, num2. So you can add this program and just call the print num and send num1 and num2 to this macro, and it will print you those numbers which you have inputted from the keyboard. Yeah, that will be great. That will be your home exercise. So, but do that to get you hold on that. If you're still not getting, I'm seeing that you are not getting this. I don't know why, but I got some intuition that you're not getting the program. So what you gotta do is just copy this program on the piece of paper, start understanding the logic, and then again listen, then again try to look on the piece of paper where you have written actually the program, and try to again listen, and you will get it. You are not that dumb, are you? Anyways, so if you are still that dumb, let me run for you actually this program. So dot exit, it is gonna say bye bye, then end start, it's gonna say tada. Anyways, let me try to print it now. Getting more funny. So tassel, what the name of this is? Add BCD, ADD, BCD. There we go. No errors. That's correct. That's the greatness about me. T-Link. Now I forget the name. In the greatness. Anyways, what now? Now let me run it. Add BCD. So what's that? BCD is an executable file, and I'm gonna run it. So it's gonna tell me please enter first 2-digit number. Don't press enters, etc. Okay, don't put enters, just press some digits, 2 then 3, 23. It will go quickly to ask you to get second number. It's very obedient fellow, आपकी तरह थोड़ी है, बड़ा प्यारा बच्चा है. So what I will do is now I will put second number, that's 56. Oh bad, you put 56, it gets, at the moment you put 6, and it will give you the sum of the 2-digit numbers is 79. Is it 79? 6 plus 3, 9, 5 plus 2, 7. Oh, it's correct. But one more caution here. This program is only for the 2-digit numbers. That means you're gonna only get 2-digit numbers, input 2-digit numbers. It will answer should also be in the 2-digit. I mean to say that. It will not allow you, आपको ये करने नहीं देगा, 3 डिजिट तो करने नहीं देगा, या आपको इंतजार नहीं करेगा तीसरे डिजिट के लिए, 2 डिजिट के लिए इंतजार करेगा. लेकिन अगर ऐसा हुआ कि आपका सम 3 डिजिट का है, it will go wanky. For example, if I add, I will again run it, BCD. I will say 50, then again say 50. So 50 plus 50 is what? 100. It will give me 0, because 100 is a 3-digit number. This program is not for the 3-digit numbers, it's for a 2-digit number. If you want to do something on a 3-digit, open up the copy, see what happens, where that one goes, and all the logic, and try to subtract things and maybe do something different, and you will be fine. So only thing in this program is that you have to, actually the most important thing in it is how to get numbers. That is get num. This is the logic. If you understand the logic, that you got 2-digit numbers, first digit rotated to the left, because first when you get the number from the keyboard, that means start a story like this. Start the keyboard, when you get the number from the keyboard, that will be ASCII. If you say 4, it will be 34. So get rid of this 3, that means subtract 34 with the 30 to get it 4 only. Put this 4 on this side. The next number when you get, say for example 5, it will be 35. Get rid of 3 again from 35 and OR them together. So 4 and 5 means 45, concatenate it together. Then add whatever you want to add. When you want to print, first put 4 here. Get rid of this part. How? By adding with the 0 FH. So only remains this part. And print it. Send it to the DL and print it to the 0 to H function. And now second digit similarly, that is here again, only get rid here, no rotation at this moment. So this number and this number, add it with the 0 FH, this is gone, only remains this. Send it to the DL, print it with the 0 to H function, and it will print it. I think that's all for today, and hopefully you have understood this. And if you like this program, maybe we show you a word of thanks actually, so you can mail me at the juny@live.in. That is JUNY@live.in, live.in. So mail me, maybe thanks or maybe something else, so that maybe I will pump up more to produce something different, so that this can help you. So anyways, Take very good care of yourselves. Assalamu alaikum.